This video is for the Facts About Chords notes. This is going to be lesson 6.3. So the chord of a circle is a line segment that joins 2 points on the circle. Okay, so like AS is a chord, BC is a chord, AD is a chord. So the chords go across the circle, but they're not the diameter. They don't go through the middle. All right, congruent chords. So 2 chords are congruent if and only if their corresponding intercepting arcs are congruent. So the bottom here wants us to name 2 congruent chords. So intercepting arc. So if I was looking at AI, its intercepting arc is all the way around the circle from A to I. So it would be 75 and 8. Okay, so let me grab a calculator really quick. Okay. So 75 plus 8 would be 83. I would need another chord that also measures 83. Okay, and so you can go along and you can kind of add up the pieces to try to get to 83. For this one, we're gonna start with HG. Okay, so chord HG. So from H, well, that doesn't work. Hang on, give me a second. Sorry, let's do HF, because there is no chord HG. So from H to F. So from H to F outside the circle we have 68 and 11. Okay, so 68 plus 11 gives me 79. So I need another one that measures 79. And if you look down here from C to E, 20 plus 59 would give me 79 as well. So those are congruent chords. So what that means is that HF, so this chord, is congruent to CE, this chord. And so it's not necessarily something that you can eyeball. You need the numbers, you need the math behind it to prove it. Oop, and that should be, it's hard to tell, that's an E. All right, diameter and chords. So the diameter of a circle bisects a chord if and only if the diameter and chord are perpendicular. So given circle A with diameter CE, so here's the diameter, and CE, so this diameter is 20 units, and chord BD, so this is BD, has 16 units. Determine the length of AF. So when we're talking about bisecting, remember we're talking about cutting it in half. And so since the chord BD is perpendicular to CE, and I know it's perpendicular because of that, I know that BD is cut in half perfectly. So if BD all the way across is 16, that means halfway across is 8. And we're trying to find the length of this, AF. So here's another bit of information they don't give you, but you're expected to know. AB, right here, that's a radius, okay, because it goes from the center. So if the diameter is 20, the radius is 10. And what we can do now, because this is a right angle, we can use Pythagorean theorem on this, okay? So remember a squared plus b squared equals c squared. The hypotenuse, the side opposite from the right angle, is always the c value, and then one of the legs is the other value. Okay, so we can solve that. And let's try menu 3-1 on this. Actually, nope, because we got an exponent, so that won't work. Okay, so we can do 8 squared, and we can do 10 squared. So we've got 64 plus b squared equals 100. We can subtract 64 from both sides, and so b squared equals 36, And to get b by itself, we just square root 36. So the length of AF would be 6 units. Okay, intersecting chords. So the measure of an angle formed by intersecting chords Sorry, mine is wrong one. The products of the lengths of the segments of intersecting chords are equal. So given circle A with intersecting chords BC, okay, intersects DE, find the length of DF, so from here to here. So the products of the segments are equal. So that means these two pieces here on BC, 5 times 8, is going to be equal to the two pieces here, x times 10. Okay, so 5 times 8 is going to equal x times 10. So 5 times 8 is 40. X times 10 is 10x. Divide both sides by 10. And that x piece, 40 divided by 10, is going to be 4 units. All right, vertical angles. We've seen vertical angles before. So vertical angles are formed by intersecting chords, or vertical angles formed by intersecting chords are equal in measure. So given circle A with angle BFD, so that's this one here, BFD, and it's 75 degrees, find the measure of angle CFE, C to F to E. So those are vertical angles. So if one's 75, then the other one's 75. All right, let's look at the back. All right, adjacent angles. So adjacent angles formed by intersecting chords are supplementary. So supplementary means they add up to 180 degrees. Okay. Given circle A with BFD, so same angle, BFD, 75. So that's this one. Find the measure of angle BAE. Should be F. Sorry. Yeah, should be BFE. Sorry. So BFE, that's this angle here. So they're supplementary because they form this straight line, which means we can take the 75 that we know and we can just subtract it from 180. So I'll write down what I did here. And our angle would be 105 degrees. All right, a little bit more about intersecting chords. So the measure of an angle formed by intersecting chords is half the sum of the measures of the intercepted arcs. So given circle A, so BFD right here is 75, and the measure of arc BD, so that's here, is 70. Find the measure of CE. So here's what we're looking for. All right, so the sum of the arcs cut in half equals the angle. So angle BFD is equal to half. So here's one arc, BD, added to the other arc. So see how they're connected? CE. And we can just fill in the blanks. That is an E. So we know BFD is 75. We know BD is 70. And CE is our X. So from this point, we can menu 3-1 it. And I'm just going to use, I'll do it this way, 1/2 70 plus X. comma, X. And that means CE is 80 degrees. Okay, so again, those intersecting chords, the two arcs that it makes here, if you add those together, this angle is going to be half of those two added together. And that's it for this video.